Okay, we're going to do some review and then we're going to get into the new topic. Okay, you need to simplify the square root of the number 48. Well, 48 is not a perfect square, so it is called an irrational square root, IRR. So then you put in your division sign, okay, and then you start trying to divide 49 by your perfect square values. It's got to be a perfect division. It's got to be an even. It's got to go into 48 evenly. 38 doesn't do that. 25 does not do that. Okay, if I divide by 16, you get 3. So I rewrite that as the square root of 16 times the square root of 3. And the square root of 16 equals 4. Okay? So we replace that with 4, and the answer is 4 times the square root of 3. Or 4 square root of 3. Now we have the square root of 32 times, put that times operator m to the 5th. Remember, in multiplication inside of one radical, you can break that up into multiple radicals so that they cover each factor independently. So the square root of 32 and the square root of m to the 5th. So 32 is an irrational square root. So that means I am dividing 32 by the perfect square values. 32 divided by 25 is a decimal. 32 divided by 16 is 2. So I rewrite that as the square root of 16 times the square root of 2. And of course, the square root of 16 becomes the value of 4. So 4 square root 2. So in this new square root, I'm going to have a 4 outside and a 2 inside, but then there's a matter of the m to the 5th. So I don't know the value of m, but I do know it's to the 5th power, so I know that there's 5 factors of it. So m times m times m times m times m. Then I'm going to break up the square root further, because it's multiplication, so that it covers 2 of the m's at a time, and then this m at the end just gets its own one. So n times m is m to the 2nd, but having the square root and the 2nd power cancel, and it gives me m. And then the same thing is going to happen here, m to the 2nd, square root and 2nd cancel, giving me m. So that we don't get that to cancel though. So we have 2 full factors of m, m to the 2nd, and then the square root over m. So we're going to have m to the 2nd outside, and then that m still inside, because I didn't get that to cancel and come out. Okay, now in these next couple problems, we have 2 square roots. We have the square root of 3x to the 3rd times the square root of 18x. Okay, so it's all multiplication. Okay, and you got multiplication inside of the roots. Okay. But all multiplication, when you have 2 different radicals and multiplications, we can break it down into 3 steps. Okay. Step number 1, you multiply the outside coefficients if there are any. And at the same time, you're going to multiply your square roots together. Well, there's no outside coefficients. Okay. There's none. Absolutely none. So we multiply the square roots together. We get that under 1 square root. So I take 3 times 18, and that's going to be 54. And then in the inside, I also have an x to the 3rd times x, which is x to the 4th. Okay. Now step 2, you need to simplify your new square root. Okay. So inside the square root, we have a 54 times an x to the 4th. So we're going to break that up, just like we did on the last problem, into the square root of 54 and the square root of x to the 4th. So 54, well, 54 is not a perfect square. It's an irrational square root. So I put in the division sign. And I go 54 divided by 49 first. That's not going to work. 54 divided by 36, that does not go into 36 or 54 evenly. 25's no. 16's no. and 9's yes. Okay, so I rewrite that as the square root of 9 times the square root of 6. So the square root of 9 turns into 3, and this equals 3 square root 6. Now the variable, we do what we did up here. We go x times x times x times x, 2 of them at a time. And then this is x second, but the square root and the second cancel, and I get x. This is x second, the square root and the second cancel, I get x, and there's no square root remaining, so there's 2 full factors of x, so there's not going to be a square root. Now remember, if there's no square root, this goes out. Okay, so now I make my new square root, I put a 3 out and a 6 in, and since all the square roots canceled here, the x to the second goes out. Okay, and then step 3 is to simplify the outside of your new square root, the outside coefficient, but this really can't be simplified because you can't take 3 times x to the second when you don't have the value for x, so this is already in simplest form. Okay, now, next problem, we have 2 separate radicals, but this one is not multiplication like this one. This one is addition. So in addition, you got to get these to be like terms. What that means is the 3's multiplied by the square root of 7, the 2's multiplied by the square root of 28. Right now they're not like terms because these outsides are not times, not multiplied by the same thing. So you want to make your table. And on one side you're going to put 3 times the square root of 7. On the other side 2 times the square root of 28. Okay, so the square root of 7 is irrational. Okay, so put in the division sign. 3 times. Okay, 7, is it divisible by 4? Nope. It would only be divisible by 1, but that just takes you back to 7. So really, this is already in simplest form. So that one's not going to change. It's going to be 3 times the square root of 7. Now in the other one, we drop our factor of 2, and then we simplify the square root of 28. Now 28 is not a perfect square either. It's an irrational square root. So then I divide 28 by 25, not going to work. 16, not going to work. 9 is not going to work. 4 does work. So square root of 4 is square root of 7. So this turns into 2. So instead of 2 times the square root of 28, we now have 2 times 2 times the square root of 7. And then 2 times 2 gives me 4. So it's 4 times the square root of 7. Okay, now we've got like terms with the square root of 7. So I write the square root of 7 down, and then I can add the outside coefficients. 3 plus 4 also gives you 7. So it's 7 square root of 7. Okay, now we're going to get into the new topic. We got to simplify these expressions. Ignore these stupid little boxes I made. Just ignore them. Okay. So we got the square root of 5, then a parentheses. Well, that means multiplication. And then 4 minus, I don't like minus in these problems, make it plus negative and put a 1 there. So now it's negative 1 times the square root of 20. Well, you can't really do please excuse my dear Aunt Sally because there's a plus, but these aren't like terms. 4 is not multiplied by anything, and negative 1 is multiplied by the square root of 20, so they're not like terms. So you need to distribute, but before you distribute, okay, and draw rainbows distributing, you need to make sure that both of your square roots have coefficient multipliers in the front. This has a negative 1. This would get a 1 then. Okay, I'm going to put a 1 there. Trust me, it will help. Now look at your non-square root values. You draw an arrow, a rainbow from the 1 to the 4, and then the 1 to the negative 1. So I'm going to take 1 times the 4, but I got to remember that the 1 is multiplied by the square root of 5. So it's going to be 1 times the square root of 5 times 4. Okay, that's the first. There's 2 rainbows, so there's 2 multiplications. Then I take 1 to negative 1, but 1's multiplied by the square root of 5, and then negative 1's multiplied by the square root of 20. Alright, now we find these products. Well, I multiply the coefficients 1 and 4. That's 4. And then times the square root of 5. Then 1 times negative 1 is negative 1. Then I multiply the square root since I have 2 of them. And that's going to be the square root of 100. Okay. Now you're not done. You're not even close to being done at that point. These can be a pain. You need to write 4 times the square root of 5 plus negative 1 times the square root of 100. And you need to simplify these. Okay. So the square root of 5. The square root of 5 is irrational. So I put in the division sign. And I'll drop the 4. Okay. However, 5 divisible by 4, no. So it would just take me to 1. Well, if I come to 1, that means I just keep it as 4 times the square root of 5. Okay. Now I drop the negative 1, and the square root of 100 is not irrational. The square root of 100 is equal to 10. Okay, so I don't do the division. I just replace it with the value of 10. So it's negative 1 times 10. I don't really like how I set that up. Okay, negative 1 times 10 is negative 10. So just put negative 10 down there. You see, this is still that, but this became 10. Now it's a coefficient. Now we can multiply. Okay, negative 1 times 10 is negative 10. And then that's the end of the problem. You don't have any like terms. See, the 4 is multiplied by the square root of 5. Negative 10 is not multiplied by anything at all. Okay, so that's going to be your answer right there. I didn't like how I set this up over here. We're going to do something different on the next one. Okay, now we got the square root of 13 times, and then 2 times the square root of 3, and then plus 3. 3 is multiplied by nothing. So I cannot add these. Those are not, see, the 2 is multiplied by the square root of 3. The 3 is not multiplied by anything, so you can't do anything in the parentheses. So you have to come out and distribute. But before you do that, make sure you got a 1 there, and this square root already has a 2 coefficient. So I distribute 1 to 2 and 1 to 3. But I got to remember, when I go 1 to 2, the 1's multiplied by the square root of 13, and the 2's multiplied by the square root of 3. And then 1 times the square root of 13 again, and then times the 3. Now the 3's not multiplied by any square root. So 1 times 2 is 2, and then we multiply the square root of 13 by the square root of 3, which is the square root of 39. And 1 times 3 is 3 times the square root of 13. Now take these over here. 2 square root 39, don't put pluses, okay? Just put them, space them out. Space out your products and see if they can be simplified. I did not like how I explained that. That was not good, okay? Okay, so 2, or the square root of 39. The square root of 39 is not a perfect square. You write irrational. Okay? So I put the division sign in. I see if 39 divides by any of the perfect squares. Drop that 2. Okay? So 39 divisible by 25. Nope. Divisible by 16. Nope. 9. Nope. 4. Nope. So that takes you to 1, which means that will just stay the same. Now, circle it. Now the square root of, again, I'm doing it different than I did up here. I don't like that. The square root of 13, okay? 13 is irrational. So put in the division sign, drop the 3 coefficient. You know that's going to be there no matter what. So 13 divided by 9, nope. By 4, nope. So that just takes you to 1. So if it's 1, you're not going to do it. And you're just going to keep it the same, okay? Now, we got, these are my 2 products. They're simplified and all that. Now in the first product we got the square root of 39. Do any of the other products have the square root of 39? No, they don't. So I put the square root of 39 down with its 2 coefficient. Now another square root you have is the square root of 13. This is the only square root of 13 I have. There's a 3 with it, so 3, and you put a plus sign between the two. So there you have it. Okay, next problem. The square root of 22 times 2 times the square root of 6 plus 3. Okay, so you can't add these because that's multiplied by the square root of 6, and the 3 is not multiplied by anything. If they were both multiplied by the square root of 6, you could add them, but they're not. Okay, so we have to do distribution. Put the 1, so 1 to 2, 1 to 3, 2 rainbows. So I got 1 to 2, but the 1's multiplied by the square root of 22, and the 2 is multiplied by the square root of 6. Then 1 to 3. Now the 1's multiplied by the square root of 22. The 3 is not multiplied by anything, so it's just 3. So 1 times 2 is 2, and then I multiply the square root of 22 times the square root of 6. Got 132. Okay, and then 1 times 3 is 3, and then we'll just have times the square root of 22. Now space these out. Write 2 square root 132, and then a little ways further, write 3 times the square root of 22. Okay, 132 is not a perfect square. It's irrational. You need to simplify that by dividing. So you drop your 2 coefficient, and then you start dividing 132. So 132 divided by 121 is not going to work. 100's not going to work. 81 is not going to work. 64, nope. 49, nope. 36, nope. 25, nope. 16, nope. 9, nope. Okay, we're going to have something with 4. 4 and 33. So square root of 4 times square root of 33, and this becomes 2. So then instead of 2 square root 132, it's 2 times 2 times the square root of 33. And then we multiply the 2 by the 2, and that's 4 square root 33. Now circle that. Okay, now we move over here. It's 3 times the square root of 22. Now 22 is an irrational square root, so we put in the division sign. Then 22 divided by 16 is a decimal. 9's a decimal, 4's a decimal, and then that just takes me to 1, so 1 means I drop the 3, and then the square root just stays the same. Okay. Now, this has a square root of 33. Put that down. Is there a square root of 33 in the other product? No, so it's just 4. Then I write plus, and then I put the square root of 22 down. That's the only thing with the square root of 22, so I just put 3 down. And there you go. Okay, next problem. The square root of 5 times 8 square root of 10 plus 1. You can't add the 8 and the 1. That's multiplied by the square root of 10. The 1's not multiplied by anything. Those are not like terms that you can add. Okay, so 1 to 8, 1 to 1. So 1 times 8, but 1's multiplied by the square root of 5, and 8's multiplied by the square root of 10. Then 1 to 1. The first one is multiplied by the square root of 5, but then the other one is just not multiplied by anything. So 1 times 8 is 8, and the square root of 5 times the square root of 10 is the square root of 50. And 1 times the square root of 5. So put those products over here, and now we see if they can be simplified. The point of simplifying it, because there's an outside chance we could get like terms. Maybe not, but okay, 50. 50 is not a perfect square. It's irrational. So you put in the division sign, drop your 8, and then 50 divided by 49, nope. 36, nope. 25, yes. So I rewrite it as the square root of 25 times the square root of 2. So the square root of 25 turns into 5. So it's instead of 8 times the square root of 50, it's 8 times 5 times the square root of 2. And of course that then is simplified to 40 times the square root of 2. Now circle that. Okay, now the square root of 5, that's irrational. Okay, and 5 is not a perfect square, so we divide. Okay, so we divide the 5 by the 4, that's a decimal, so that just takes you to 1. That means we can't simplify this, it's just going to be 1 times the square root of 5. Now look at your two products. The first product has the square root of 2. This does not have the square root of 2, so that remains 40. Okay, plus, and then the square root of 5, that's the only product that had a square root of 5, and then 1. 40 square root of 2 plus 1 square root of 5. If you looked up the answer in a textbook, that 1 would not be there. Okay, now this one gets a little more dicey. You've got the square root of 7 plus the square root of 2 times the square root of 7 minus 3. Make that plus negative, please. Square root of 2. So we got addition in each parentheses, but they're not like terms. Okay, so we're drawing rainbows. This time we are going to have 4 rainbows. It's going to be the FOIL method. Okay, so don't go in the same parentheses. Take this 1 and multiply it by 1, and then 1, multiply it by negative 3. But the 1 is multiplied by the square root of 7, and the 1 here is multiplied by the square root of 7. Now, the second rainbow, 1 times the square root of 7 times negative 3 times the square root of 2. Okay, I'll find these products here in a bit, but first I got to do my other distribution with the 1 times the square root of 2. Okay, so 1 to 1 and 1 to negative 3. So 1 times the square root of 2 times 1 times the square root of 7. 1 times the square root of 2 times negative 3 times the square root of 2. So that's a FOIL problem. Okay, so 1 times 1 is 1. The square root of 7 times the square root of 7 is the square root of 49. 1 times negative 3 is negative 3. Square root of 7 times the square root of 2 is the square root of 14. 1 times 1 is 1. The square root of 2 times the square root of 7 is the square root of 14. 1 times negative 3 is negative 3. The square root of 2 times the square root of 2 is the square root of 4. Now you got 4 products. Just space them out. 1 times the square root of 49. Negative 3 times the square root of 14. 1 times the square root of 14. And then negative 3 times the square root of 4. Now, square root of 49 is not irrational. Drop your 1, but it's 7. You don't divide, you just replace it with 7, so it's 1 times 7, and that's 7, so no square root. Square root of 14 is irrational. It's not a perfect square, so you start dividing. Drop your negative 3. So 14, is that divisible by 9? Nope. Is it divisible by 4? Nope. So that takes you to 1, which means it's already in simplest form. And then we know that's in simplest form because it's the same thing here. 1 times the square root of 14. Now the square root of 4 is not irrational. Okay, you drop your negative 3, but you don't label it irrational and divide. You replace the 4 with 2. So negative 3 is 2, and that's negative 6. Now here are my 4 products. You need to circle those. So 7 isn't multiplied by a square root. Is there any other of the 4 that is not multiplied by a square root? Yeah, the 7 and the negative 6. Neither of those is multiplied by a square root, so we add those. Okay? So 7 plus negative 6 is 1. So that takes care of these. Now, you got negative 3 multiplied by the square root of 14. So we got the square root of 14. Is this one multiplied by the square root of 14? It is, so we add the negative 3 to the 1, and that's negative 2. So we had 2 sets of like terms with these, and then these. Okay, now, 2 times the square root of 3 plus 5, and then to the second power. So we can't add, they're not like terms. So we get rid of this second power, and just make another parentheses just like the first. 2 times the square root of 3 plus 5. That's another FOIL. We go 2 to 2, but both the 2's are multiplied by the square root of 3. We can't forget that. And then 2 to 5. The 2's multiplied by the square root of 3. The 5 is not. It's the FOIL method. Just instead of with variables, it's with radicals. That's done. Now you take 5 to 2 and 5 to 5. 5 is not multiplied by anything. The 2's multiplied by the square root of 3. Okay, and then 5 times 5. Neither 5 is multiplied by anything. So 2 times 2 is 4. The square root of 3 times the square root of 3 is the square root of 9. 2 times 5 is 10 times the square root of 3. 5 times 2 is 10 times the square root of 3. And 5 times 5 is 25. So we have 4 times the square root of 9. 10 times the square root of 3. 10 times the square root of 3, and then just 25. So the square root here, we drop the 4, but the square root of 9 is not irrational, it's rational. So you don't put IRR, you just replace it with 3, and then 4 times 3 is 12. Okay, the square root of 3, well, that's definitely irrational. 3 is not a perfect square, so we divide. And the only thing, well, that would just be, it's already simplified, okay? You only could divide it by 1, which means you want to just keep it. And then the same thing's going to happen here, because now this is already in simplified form, okay? 25, there's no square root to simplify. Okay, first let's look for numbers without square roots. Well, we got 12 and 25. We add those. That's 37. That takes care of those. Now we got the square root of 3. Write it down. Now you also have the square root of 3 here, which now you're allowed to add the 10 and the 10. That would make 20. Okay, 37 plus 20 square root of 3. Okay, next problem. Plus negative, put a 1. You know those can't be added. That's multiplied by something. That one's not. Plus negative 1. Okay, so 4 to 1, 4 to negative 1. But so the 4 is not multiplied by anything, and the 1 there is not multiplied by anything. And 4 again. 4 is not multiplied, but the negative 1 is multiplied by the square root of 5. Okay, then negative 1 to 1. So negative 1 times the square root of 5 times 1. The 1's not multiplied by anything. Then negative 1 times the square root of 5 times negative 1 times the square root of 5. So this is 4. This is negative 4 times the square root of 5. This is negative 1 times 1 is negative 1 times the square root of 5. Negative 1 times negative 1 is positive 1. And the square root of 5 times the square root of 5 is the square root of 25. So we got 4. Negative 4 times the square root of 5. Negative 1 times the square root of 5. And then 1 times the square root of 25. So this 4 is already simplified. Square root of 5, well, I'll drop my negative 4. The square root of 5 is irrational. It is not a perfect square, so you put in the division sign and then divide 5 by 4, decimal. Then you're just a 1, which means it's already in simplest form. And then the square, this one's already in simple because it's the same square root that one is. Negative 1 times the square root of 5. Okay, now 1, the square root of 25 is rational. It's equal to 5. Okay, so 1 times 5 then is 5. So what what products did you end up without square roots? Well, the 4 and the 5. That would be 9 when you add those. Then you got the square root of 5 plus. And this one's a square root of 5, so you're allowed to add these. These are like terms. Negative 4 plus negative 1 is negative 5. Done. Okay, then our last one. 6 plus the square root of 3 times 6 minus, make that plus negative 1 times the square root of 3. So again, we can't add there. Those aren't like terms, because this would be a 1. So we do the FOIL. So 6 times 6. 6 times negative 1, but the negative 1 is times the square root of 3. Then positive 1 times 6, but the positive 1's multiplied by the square root of 3. The 6 isn't multiplied by anything. Then positive 1 times the square root of 3. And then negative 1 times the square root of 3. Now you can multiply. So this is 36. That's negative 6 times the square root of 3. That's positive 6 times the square root of 3. And this is negative 1 times the square root of 3 times the square root of 3 is negative 9, is 9. Okay? So we got 36, negative 6 times the square root of 3, positive 6 times the square root of 3, and negative 1 times the square root of 9. So that's already simplified. Square root of 3 is irrational. So I drop the negative 6, put in the divide, but the only thing 3 is going to be divided by is 1. Okay? So just keep it square root of 3 and circle it. Same thing here. Okay, so negative 1, but the square root of 9 is not irrational, so we just replace that with 3, and it's negative 1 times 3, and that's going to be negative 3. So I add the values that do not have the square roots. 36 and negative 3 are added, that's 33. And then I got the square root of 3. So plus, put the square root of 3 down. Now how many products are multiplied by the square root of 3? Well, both of these are. But a funny thing happens. Negative 6 plus 6 is 0. If you end up with a 0 that is taken out, get the plus sign and the answer is just 33.